Hi, my name is Shipra and I'm going to talk about mutual exclusion. And for that, I read the paper that is an optimal algorithm for mutual exclusion, and this is the paper. Now, let's first talk about what mutual exclusion is. Whenever the multiple processes are trying to access the same resource, there can be conflicts in the network, and some of the process will not able to access the resource, and there could be the data inconsistency issues. So in order to avoid those conflicts, we have these algorithms. So these algorithms make sure that there is no problem of deadlock, or there is only one process that can access the resource at a time. Now we have two categories of distributed mutual exclusion algorithms, and these are token-based solutions and permission-based solutions. So in token-based solution, there is one token in the entire network, and we have multiple processes. So the process that has the token will be able to access the resource, and once the process is done accessing the resource, it will pass the token to other processes in the network. So that's how this token-based approach works. Now, this approach makes sure that there is no problem of deadlocks and starvation, as it provides the mutual exclusive access to the processes on the basis of the token. But now there is one major drawback of this approach, as this network is relying on the token, and if the token is lost, the entire network will not work. Next is the permission based solution. In this, if the process tries to access the resource, so it will send the permission message, the request message, in order to grant the permission to other processes in the network. So once it gets a permission, it is free to access the resource. Now we have algorithms that are based on this permission based approach, and these are a centralized algorithm and a distributed algorithm. Now for centralized algorithm, as you can see in the diagram, we have one coordinator and we have multiple processes like P0, P1 and P2. So if process P1 wants to access some of the resource, so it will send the request message with the process ID and the resource ID it wants to access. And once the coordinator gets a request message, it will see that if the resource is available or free to be available for the process P1 to access, and it will check the queue. So after that, it will send the OK message or the grant message to the process P1. So after getting the access, P1 is free to access the resource. So now in the second diagram, as you can see, P2 also wants to access the same resource, and it will send the coordinator, it will send the request message to the coordinator. But now coordinator will see that the resource is not available, so it will put the process P2 in the queue, and it will not send any reply to process P2. After that, once P1 is done accessing the resource, it will send the release message, and that's how the coordinator will get to know that now the resource is available, and it can send the OK message to P2, and it will remove the process P2 from the queue. So that's how this centralized algorithm works. Now we have various advantages of centralized algorithm, like it guarantees the mutual exclusion, because at a time it allows only one process to access the resource. And other advantages are like there is no problem of starvation and deadlock. Again, it's the same thing, like it provides a mutual exclusive access to the resources, hence there is no deadlock problem. And this algorithm is also easy to implement, as we have just 3 messages per resource, like request message, OK message, and then release message. But now it has a disadvantage, as we have the coordinator in this network. So as we can see that it's a single point of failure. If the coordinator is down, the entire network is down. Now the next algorithm is the distributed algorithm. So it is based on the priority, like whatever process comes first and request to access for the resource first, it will get the access. And this priority is on the basis of the timestamp using the logical clocks. Now in this case, the requester will send the message with the resource name, process ID, and the current logical time. And the receiver, who will get the message, can take three actions, like it can send the OK message, or it will not reply because the resource is currently being used by this this process. And another action is if the receiver process also wants to access the resource, so in that case the timestamp of the two processes will be compared and the lowest one wins. So as you can see in the diagram, we have three processes like 0, 1, 2. So 0 will send message to 1 and 2 with the timestamp 8. 2 will send 2, if 2 also wants to access the resource, so it will send the request message to 0 and 1 with timestamp 12. Now as the process 1 doesn't want to access the resource, so it will send the grant message OK to 0 and 2. But now here is a conflict, like 0 and 2 wants to access the same resource. So now the lower timestamp is with 0. So 0 will get the grant and it will be able to access the resource. And after that, once the resource is free, 0 will send the OK message to the process P2. So that's how this algorithm works, and we have various advantages, like it guarantees mutual exclusion, and again there is no problem of starvation in deadlock. Now paper says that it is an optimal algorithm because we have just n minus of 1 messages, like send and receive messages, because as you can see, one process will send request message to n minus of 1 processes, and it will also receive n minus of 1 response. So there are just 2 into n minus of 1 messages in the algorithm. But now it has n points of failure and we have to maintain the membership list also. But this is a better algorithm than the centralized algorithm. And here these are the references, and that's it. Thank you.